Hello friends, today we will be assembling this quadcopter based on a Chinese IP camera. The drone turned out great, but it's a bit heavy, although of course this is all subjective when it comes to weight. I will tell you how everything is assembled, and at the end we will conduct test trials, so let's get started. I have a 5-inch frame, but I use it for visual flights, because there is little space to place the equipment here. In this case, a bus type frame is more suitable. An IP camera and a Wi-Fi module will also be needed. I will use BL-M8812EU2. This is an analog of the previous module, but it is more affordable and budget friendly. If I'm not mistaken, its power is about 800 millibars. And they provided me with 2 antennas for 5.8 GHz. 2 pieces. You may also need a backup. The backup should be 5 volts and approximately between 3 to 5 amperes, depending on the power of your Wi-Fi adapter. But I won't need it, as my flight controller has 2 backups. Well, in my case, usually, a flight controller has 2 backups. One is for 9 volts to power the video transmitter, and the other is for 5 volts to power the camera. In this case, I have them at 3 amperes, which amounts to 15 watts and 27 watts. Connectors will also be needed to connect the camera. This is to avoid soldering. 2 4-pin connectors and 1 2-pin connector. At one time I bought a pack of such connectors and now I use them. I designed the case, and now I want to try it on. On one side, the lens board is installed. There is a slot on the side for easily connecting the ear-cut connector. I carefully connected the ribbon cable, and am installing the rear part, and all of this is secured with standard M2 screws. I connected the power connector, followed by UART and USB. I route the contacts outside through a special slot in the cover. I will secure everything with M2 screws of 12 mm. Next, I will install the antennas and the Wi-Fi module. Additionally, I will secure them with hot glue. I am soldering to the USB. To power the Wi-Fi module, it is better to use thick wires, as this will result in less voltage drop. The weight of the camera without the radiator is approximately only 60.5 grams in total. I soldered thick wires to the 5-volt output of the flight controller and thin wires to the 9-volt output. And 2 others to the free UART port. So friends, everything is connected, and I'm doing the first test. The only thing is, I don't have a laboratory power supply, so I will be connecting batteries. But it's better not to do that, because this battery can deliver a lot of amps and burn everything out. So, let's go. So, the quadcopter itself is working now. Let's see if the image has appeared. The image hasn't appeared, so I will figure it out. Everything is working now, but I had to swap the USB contacts and reflash the camera because the new firmware already includes the driver for the Wi-Fi module RTL8812EU. In laboratory conditions, everything works and the delay seems to be small. Now it is possible to go test it outside. Located in the car trunk, we have the quadcopter, which we will safely launch. The goggles are carefully connected to ROXA via an HDMI cable. Unfortunately, I successfully burned out the orange pie. I will explain what happened later. From ROXA, there is a USB cable going to the Wi-Fi module, which I have right here. Here I have two antennas, one directional and the other regular. At the top, the bitrate is displayed. Currently, it is approximately 9 megabits. Next are the MCS parameters and the guard interval, which are responsible for the link speed. Then there are the FAC values needed for recovering lost packets. Next is the CPU load, the current bit rate, which for some reason is 17 megabits instead of 9. Interestingly, the frame rate is 120 FPS and the temperature of the chipset. The Betaflight OSD is displayed at the bottom. I set 3 bitrate options on the hardware: 16 megabits, 9 megabits, and 3 megabits. The first test at 9 megabits starts off well. The image is sharp and contrasty, and there is no noticeable delay. Now I will try to fly below. In this situation, the connection is lost because direct visibility is obstructed, and I ascend upwards. After that, the connection is restored. Yes, and I immediately switch to 3 megabits per second, and I will try to make a second round. It is immediately clear that the picture is a little worse. This time the situation is much better. Even in the absence of direct visibility, the image continues to be displayed. Only now has there been a loss of connection. Let's try flying in the other direction. I have slowed down to take a look at the design of the image. And I fly into the veil to check the quality of the connection. And the picture was lost. Most likely, this is due to the fact that my antennas are pointed 90 degrees in the opposite direction. Now I will try to fly there with a bitrate of 3 Mbps MCS0 and the maximum power that this Wi-Fi module can provide. At 3 Mbps, the image becomes blurry, but it somewhat resembles analog quality. It can also be perceived only by touch. Alright, I flew into the same area. All the antennas are pointed in the same direction as last time. And now the connection is quite good with no delays or losses. So, my battery is starting to run low. Let's fly a bit deeper. And I'll try to switch to 9 megabits. Let's see what changes. Oh, something is making me lose balance. Oops. Damn, I haven't flown in a while, so I couldn't handle the controls. In total, I flew 4 batteries, but not everything was recorded. Apparently, due to some issues with the ground station, that's everything I have shown you in this video. I flew far to the river, which was about 500 meters from my location. The picture there was excellent, without any loss of connection. I like the detail in the image. I don't know if YouTube will convey it, but for example, in analog, you can't see the branches of the trees, whereas here you can, which is already good. There is one major downside, which is the lack of automatic bitrate switching. If you don't want connection problems, fly at MCS 1 or 0 and a bitrate of 4 megabits per second. The quality will be average, but you won't experience frame drops. In my case, I tried 16 megabits and the quality is very good for the H.265 codec. But when you fly far enough away or lose direct visibility, the picture immediately deteriorates. Currently, an adaptive link is being developed in OpenIPC, but it won't be available anytime soon. Perhaps in the next video we will actually try to test it. There are already some developments in place, an automatic installation script has been written, and basically anyone can try it out and become, so to speak, a beta tester. At the end of the tests, I had a hard landing and something happened to the radio transmitter. Right now, it is outputting minimal power. That is, even on the table, I am getting something like -90 dB on the receiver. I will figure it out. In the meantime, the module called Mario FPV has already flown into me. This is what it looks like. I hope there will be a review of it in the next video, so don't forget to subscribe so you don't miss it. And of course I'm waiting for your like, subscription and a cool comment. Bye!